Hi, my name is Calvin Chang, and today I will be presenting WikiHan, a new comparative dataset for Chinese languages. WikiHan is a dataset containing 67,000 plus pronunciation entries across 8 modern Chinese varieties and Middle Chinese. The data originally comes from Wiktionary and romanized form, which we converted into IPA. We then validated our dataset on the Protoform reconstruction task. Both our code and our data are publicly available. To provide some context, the Chinese language family consists of many mutually unintelligible varieties, which linguists usually cluster into 7 subgroups: Mandarin, Yue, Wu, Ming, Hakka, Gan, and Xiang. In most Chinese-speaking societies, Mandarin is the language of administration, leaving non-Mandarin varieties to daily conversational speech. As such, these varieties are usually not written. It is still possible to write these spoken varieties, though, with Han characters or romanization. As we see from this example, each variety has its own divergent romanization. Now, most scholars of Sinitic believe that all varieties except for Min descended from Middle Chinese. Middle Chinese is the set of old varieties documented in the Qieyun, a rhyme dictionary compiled in 601. Over time, the spoken varieties diverged from standard written Chinese. As such, many words in these spoken varieties lack a clear-cut corresponding Han character for transcription today. However, scholars have been able to trace many original characters in Middle Chinese or Old Chinese from which modern characters descended. It is possible to recover the pronunciations of these original characters in Middle or Old Chinese through protoform reconstruction. Protoform reconstruction is the inference of morphemes or words as they appeared in the ancestral languages of a set of daughter languages. The inputs to the reconstruction are sets of cognates, while the outputs are protoforms corresponding to each cognate set. Cognates are words deemed to descend from the same ancestral form, while a protoform is this ancestral form that exists in the proto-language. In our case, we're trying to predict protoforms in Middle Chinese. When we first downloaded the data from Wiktionary, we noticed that the snapshots only stored romanizations. Now, during reconstruction, though, we want to compare phonemes, not graphemes. As such, we used epitran to convert each variety's romanization to IPA. As for the Middle Chinese entries, we used a 2-stage process. First, we extracted transcriptions of Middle Chinese pronunciations from the Qieyun, or rather a digital copy of the Qieyun, using Baxter and Sagart's transcriptions. Baxter and Sagart have supplied transcriptions for each of the equivalence classes created by the rhyme dictionary. From Baxter and Sagart's transcription, we then convert this into IPA using epitran. As for how we establish cognacy, we note that we first restrict the dataset to single characters and exclude compound characters on Wiktionary. This avoids issues of partial cognacy that may arise when considering compound words with 2 or more characters. We then assume that readings grouped under the same character by Wiktionary are cognates descended from the same original character. So in the example on the right, all pronunciations are grouped under the same character in Wiktionary, and we put them all into the same cognate set. For heteronyms, or characters with multiple pronunciations, we place Wiktionary's groups of pronunciations into separate cognate sets. For example, this particular character has 2 pronunciation groups on Wiktionary, and as such, in our data set, the character has 2 cognate sets. We also choose the dialect with the most data on Wiktionary to represent the subgroup. Now let's talk about our experiments. We validated our data set on the protoform reconstruction task by running 3 different models on our dataset. One of these models was Meloni et al.'s character-based seek-to-seek model, which was originally designed for Latin protoform reconstruction. We re-implemented their model in PyTorch. We also introduced 2 baselines. The random daughter baseline in particular randomly designates a daughter as the protoform, which means no sound change occurred from Middle Chinese going to the daughter languages. The majority constituent baseline first separates the daughter forms into constituents, onset, nucleus, and coda, and takes the most common phoneme sequence within each constituent across a cognate set. This is based on a majority wins heuristic from historical linguistics. We evaluated each of the 3 previous models using 3 different criteria. Accuracy is the percent of reference protoforms that the model reconstructs exactly with edit distance 0. Phoneme error rate counts the number of edits between the hypothesis and reference in terms of phonemes, not characters, and then normalizes those edits by the number of phonemes in the reference. This accounts for the fact that many phonemes require more than 1 character to encode in Unicode. Now, feature error rate takes the edits calculated in terms of articulatory phonetic features from Panphone, which allows us to assign partial credit to phonetically similar hypothesized phonemes while penalizing phonetically distant hypotheses. Here are our experimental results. We see that across each of the 3 evaluation metrics, Meloni et al.'s model outperforms both baselines. Some additional preprocessing steps that we'd like to mention involve tokenizing by phoneme, not character, filtering out cognate sets with 4 entries so as not to bias varieties with more data, such as Mandarin, taking the first pronunciation variant within a cognate set arbitrarily, including min as if it descended from Middle Chinese, and finally, concatenating all daughters in a cognate set, separating varieties with the language code. In this work, we've created a large dataset of Chinese varieties intended for a computational protoform reconstruction of Middle Chinese. We hope to reduce the number of sources that Chinese historical phonologists must consult. But our dataset can be used for much more. Such uses include cognate prediction, dialectometry, building phylogenetic tree models of the Chinese language family, building phonetic language models in speech, and estimating phone distributions in those resource varieties for speech. If you have any questions, feel free to leave an issue on our GitHub repositories. Thank you.